welcome back to another video of Calculus Universalis. Today we're going to be going over LHopitals rule. So what is LHopitals rule? It allows us to solve indeterminate form limits, often rationals or exponentials. So we're going to go over a few problems. Let's hop right into it and I'll explain as we go along. So let's go. So our first problem is going to be solving the limit as x goes to 0, sine of x over x. Now you may have just memorized this as 1, but you don't know exactly why. Now what LHopitals rule allows us to do is, for some reason, we're allowed to take the derivative of the top and the bottom separately, not using quotient rule, just the top and the bottom. So we're going to go ahead and do that and rewrite the limit as x goes to 0, and then we're going to take the derivative of sine of x, derivative of x, and keep them in their respective places. So the derivative of sine of x is going to be cosine of x, which we know, positive cosine of x, and then the derivative of x is 1. And now this is solvable because it's not 0 over 0 anymore like it was over here. It's now 1 over 1. That's where it comes from. Sine of x over x. Limit as x goes to 0 is 1 because cosine of 0 is 1. And when we take the derivative of the top and then take the derivative of the bottom and plug in our limit, we now get a solvable rational limit. And plug in 0. Cosine of 0 is 1. So our answer is 1. And that's our first example for LHopitals rule. Now the next one I'm going to have you try on your own because it's a pretty simple concept. So let's say we have the limit as x goes to infinity of x over e to the x. Now this becomes infinity over infinity, and that's a problem. It doesn't cancel out and become 1. It's indeterminate in this form. So we have to do it rewriting it. Take the derivative of the top and the bottom. It's going to be 1 over e to the x, stays the same, and this becomes 1 over approaching infinity. So then this whole thing approaches 0 because the bottom becomes infinitely big, so the fraction becomes infinitely small, and the answer is 0. Now one more little practice problem. Any time to try it? Let's go. So we're going to have the limit as x goes to 0 from the right of x times ln x. And this is going to be 0 times, well, it's going to become negative infinity over infinity because we rewrite this as ln x over 1 over x, and 1 over x becomes infinity as it goes to 0, and then as ln x goes to 0 it also becomes infinity, so we have negative infinity over infinity, and that's indeterminate, so we take the derivative of both and we get limit of this over x squared, and this simplifies to negative x, and this just becomes 0. So that's our last example for today. Thank you for watching. I hope this helped. Make sure to like, subscribe, comment, and let me know if this helped.